Okay, so today we're doing solving systems using substitution. We did graphing yesterday. Okay, what did you do when you graphed? You graphed them and saw where they what? Intersected. Okay, so today you're solving it the same way. You get the same answer. You're just not graphing it. You're doing it algebraically. So to substitute, what does that mean? Jolie, what's just substitute mean?
Fill in something with another thing.
Okay, and the two things have to be what?
Put together. They have to equal the same thing. So,
What? Say it louder. They have to what?
equal the same
They have to be equal. Okay. If I gave you, say you play baseball, I coach, you know, y'all know, and I substituted a bat with a pool noodle, is that gonna have the same thing? No. Okay. If a guy in the major leagues, if he breaks his bat, they give him another bat that's like the one he broke. You got me? They have to be equal, or it's not doing any good. All right. So in order to do substitution, you have to know y equals something or x equals something before you can use it. Okay. So here, do I know y equals something? Yeah. What does y equal? 6x plus 7. Okay. Now I'll admit, if they both say y equal blah, 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 I might graph it because it's all I got to do is put it in my calculator or graph it on a piece of paper and it's done. I don't have to move anything or anything like that. But notice this one is not y equals. That's okay. We're doing substitution today. So what I'm going to do, I'm going to take what y equals, 6x plus 7, and I'm plugging that in for y in the other equation. Okay? Plugging that in for y in the other equation. Let's see if I can make that bigger. Oh, yeah, that's much better. So, plugging that in, and I'm going to plug it in for y. Now, please remember, always, whenever you're plugging something in for something else, whenever you're substituting something for something else, put parentheses around it. Okay, so I'm going to rewrite this equation, 3x minus 8. I'm not going to put y, I'm going to put parentheses. And in the parentheses, we're going to put what y is. What is y? 6x plus 7. Okay? And now you solve it. Now it doesn't have two variables anymore. It just has what? One variable. So I can actually solve it for the missing variable. You're solving for x. All right? So I'm going to distribute. That will be 3x minus 8 times 6 is 48x minus 56 equals 4. And you work it. What's 3x minus 48x? Can I subtract those? Are those like terms?
Yes.
Yes. So 3x's minus 48x's. How many x's I got?
Negative 45.
Negative 45x's minus 56 equals 4. What do I do next?
So we add 56.
Add 56 over. Negative 45x equals 60. Last step. Divide by negative 45. Okay? Went too far. So, put that in your calculator or do it in your head, whichever way you can. What is that?
Negative 1 1/3.
Negative 4/3 or 1 1/3. Just so you know, the answer probably needs an improper fraction or a decimal, okay? And if it's a decimal that keeps going forever, probably want the fraction, all right? That way you don't have to round or anything. Now, we've got x. But if you remember yesterday when we were graphing them, how many? We had an x and a what? And a y. So we hadn't found a y yet. Well, what do we do with the x?
Plug it in.
We substitute again. We take what x is, right? X is negative 4/3. And I'm going to substitute it up here into that problem that we had to begin with for x. Okay? So y equals 6 times, what did we find x to be? Negative 4/3. And then plus 7. Understand, we're rewriting this equation. We're just, instead of putting x, we're putting negative 4/3. And we work that out. So when you multiply that out, you'll get -8 plus 7. So y is, what's -8 plus 7?
-1.
-1. So my answer is -4/3, -1. Okay? If I had graphed it, would I have gotten a different answer? No. Where do they cross? Where do their cross cross? -4/3 and -1. It's the same thing. It's the same answer. Everybody good so far? All right, let's try another one. Example 2. And I can go back later if I need to, okay? Example 2. Already starting with the word problems. No big deal. A vacation resort offers surfing lessons and parasailing. If a person takes a surfing lesson and goes parasailing, she will pay a total of $175. On Friday, the resort collects a total of $3,101 for the activities. How much does each activity cost? Now, here we have the two equations. I'm going to pretend like we don't have. So let's act like we didn't know that. Okay. Let's make up our own equations. If you've already seen them, pretend like you didn't know. Okay. So here we go. Here's our options. If a person takes a surfing lesson and goes parasailing, she will pay a total of what?
$175.
That's one equation. Okay. So make your variables. You can make them whatever you want to. I try to make them where I understand what they're talking about. So like for parasailing, I might use what? P. For surfing, I try to stay away from S because S's look like 5s when you write them. Okay, so I might do L for lessons. Okay, and L kind of looks like a 1, so I'm kind of out of luck. So just pick something that you know what it is. Okay, I will use S, and we'll just make sure. Hey, that's an S. Okay, so if I take a parasail lesson or parasailing plus a surfing lesson, that's going to equal how much? $175. Okay. On Friday, the resort collects a total of $3,101 for activities. How much does each activity cost? Okay. So, how many people? It says 16 people go parasailing, 20 people take surfing lessons. So, 16 people. Put 10 for some reason. 16 people are going parasailing, plus 20 people are taking surfing lessons. That's going to equal how much for the day? $3,101. That's my two equations. That's what I'm going to use to find out what the cost to parasail and what the cost to surf is. That makes sense? Okay. So when they give you the equations, I never really consider those word problems because they're just problems with words, okay? A word problem is when you have to come up with the equations yourself. That's a true word problem, okay? So does everybody understand how we're coming up with those equations, all right? Now, we want to solve it by substitution. So I told you before, in order to do substitution, you got to have x equals something or y equals something, correct? We don't have that, and plus we have p and s. So just understand that's the same thing. So do you want to solve for p or s, or does it matter? It doesn't matter. Okay, so I'm just going to solve for p. All right, if I want to get this for p, p is going to equal how much? What am I going to do with this s? I'm just going to subtract it over. So 175 minus s. That's p. What do I do with that? Plug it in for p and s. So here's p. Can y'all still see that? All right, I'm going to take that and I'm going to plug it in for p right there. Everything else stays the same. So 16 times my p, 175 minus s, and I write the rest of it just like it is, plus 20s equals 3101. And I work my problem. Now I have only one variable, s. So I need your help on that one. What's 16 times 175?
2,800.
2,800 even?
Yes.
All right.
Yes.
16 times negative s will be negative 16s. Plus 20s equals 3101. what do I do with the 2,800? I subtract it over. So minus 2,800 on both sides. 301. Negative 16s and 20s. Can I add those? Yes. So what will that be? 4s. And then we divide by 4. I'm running out of room. Come up a little bit. So how much does it cost to surf? To get a surf? $75.25. What do I do with that to figure out what it costs to parasail? I'll plug it back in. All right. We already know parasailing is $175 minus how much it costs to learn to surf. So we can go parasailing for the rock bottom price of $99.75. So parasailing costs $99.75. Surfing costs, well, I mean,
Yeah.
it's actually a very not weird at all because, you know, they always like, oh, it's $19.99 or what, you know.
Yeah, I thought it would be 99.
Yeah, okay, I get what you're saying, yeah. That's true. 75 cents is kind of, okay. That's like, just take my other quarter, you know. All right. Any questions on that? Everybody good? Same thing we were doing on the first one. It's just word problem, okay? Sometimes, example 3, sometimes something happens, and we'll just work it, and we'll talk about it, all right? This will sometimes happen. It doesn't happen all the time, but it does occasionally. Do we know an X or a Y? It's a Y, okay? So I'm going to plug Y in for that Y. So 6x minus 2 times 3x plus 1 equals negative 2, okay? And to be honest, one of the biggest mistakes people make is they plug Y in for X or do something silly like that, okay? Make sure you're plugging a Y in for Y, all right? When you work this out, 6x minus 2 equals negative 2. And, well, what happens there? This cancels, right? All right. And I'm left with negative 2 equals negative 2. Is that true?
Yes.
Yes. If it's true, you have infinite solutions. And infinite solutions simply means that, hey, those are the same lines. They're just, the equations are different, okay? Is infinite solutions the same as all real numbers?
No.
No, okay, we talked about this already? Okay, remember, infinite solutions means not everything works, but there's an infinite number of combinations that do work, okay? So as soon as you get something like this, you can stop infinite solutions, okay? What if I got something that wasn't true? What if it said negative 2 equals 6? It's no solution. That means nothing works, okay? It also means the lines would be what? Parallel, okay? They're not going to touch. What does this mean the lines are? They're the exact same. You have one line on top of another line, and they're intersecting everywhere, okay? That makes sense? All right, last example. Oh, great. Another word problem. Nate starts a lawn mowing business. In his business, he has expenses and revenue. Nate's expenses are the cost of the lawnmower and gas, and his revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? All right, so first off, we got expenses, revenue, right? Okay, so expenses. What are his expenses? It tells you over there in the picture.
Lawnmower and gas.
Lawnmower is how much? $200 for the lawnmower. Plus, how much every time he mows does he have to pay for gas? $2 per lawn. Okay? All right. His revenue. How much is he making every time he mows one? $25 per what? Yard. Okay. Does he get a bonus or anything? No, it's just flat 20 every time he mows the grass, $25. Okay. It says, at what point will Nate's revenue exceed his expenses? So, in other words, at what point does he start making money? Okay. Sometimes that's referred to as the break-even point. All right. When is he has to make this? He has to mow this many lawns before he makes any money. Okay. So to figure that out, the break-even point is where these two things are what? Equal. Okay. So if I wrote E equaled R, okay, expenses equals revenue, and then I just substitute these in, okay, what is E? 200 plus 2L has to equal, R is 25L, and then that's going to give me how many lawns I have to mow when we are exactly the same, okay? And then you'll know, you just have to mow what? If I want to know when will the revenue exceed the expenses, I gotta mow one more yard, and I'll be more, okay? So let's figure this out. What would I do to solve that? Subtract 2L from both sides. 200 equals 23L. Now what? Divide by 23. How many lawns do I have to mow?
9.
Well, tell me what I get right here. 8 point what now?
It's
8.
8.695.
695, blah, blah, blah. Okay. Now, again, obviously, in real life, I think we talked about this. It doesn't matter if that was 8.2, we would still round what? Up, because nobody's going to pay you for mowing 0.695 of their yard. Okay. You got to mow the whole thing, or guess what? You're not getting any money. All right. So he's got to mow how many yards? 9 lawns. Okay. All there is to it. Any questions? All right. Hey, you folks in internet land, you stay above the line. Have a great day. We'll see you at the next lesson.